Okay, so let's do another example of addition here. We have two 4-bit binary numbers. 0 plus 0 is 0. 1 plus 1 is 2. So we write a 0 and we carry over 1, 0, and we carry over. Now here's an interesting thing. So now 1 plus 1 plus 1 is 1 with a carryover of 1. That is fine when we're doing math on a piece of paper as human beings. But that becomes an issue when we're talking about computers. Computers have a set register size, right? Computers are typically 32 or 64-bit. If you had an old Nintendo, that was 8-bit. If you had a TurboGrafx-16, that was actually two 8-bit processors. They lied to you. It was not a 16-bit machine. But whatever computer you have, there's a finite size of the register. What that means is, and this is one of the things we talk about a lot in CS-51, that means the numbers for a 32-bit machine are 32 bits across, right? That's all the register can represent. When you add two 32-bit numbers, if there's a bit that carries over to the 33rd position, that's called overflow, and that's usually a problem. Not always, but usually overflow indicates that a number is too large to be represented. So we usually have things in software that will handle that, or we'll have the processor throw an error and we'll handle the error. But I just want you to be aware that the way we do math, in class, is not exactly the way that the computer does it because of that limitation, that overflow limitation. There's another issue. Suppose I have 1 0 1 0, and I subtract. Well, this is our 1's place, our 2's place, our 4's place, our 8's place. This is 6 minus 15, right? Now we know in decimal that 6 minus 15 is going to get us -9. How do we represent -9? That's something we haven't talked about yet. This is called an underflow. And that's what we're going to talk about in the next example.